Okay, so on problem 6 of the exam, we're given the function f of x equals cube root x times e to the x, and we're told to find and classify all critical points. So first, we need to find the critical points. That means we set f prime equal to 0, or see if there's any place where f prime is undefined. So f prime requires the product rule, so we get two terms, derivative of e to the x times cube root x plus derivative of cube root x, which is 1/3 x to the negative 2/3, times e to the x. We want this to be equal to 0. E to the x is never 0, so we can just divide through by that and get x to the 1/3 plus 1/3 x to the negative 2/3 equals 0. And this, if we rearrange it, means that x is equal to negative 1/3. So this is the only critical point we get from setting the derivative equal to 0, but 0 is also a critical point. This is because of this x to the negative 2/3 power. That's undefined at 0, and so the derivative is undefined at 0. So we have two critical points to consider. So we draw a number line of f prime. And we have to think about how does the derivative change sign at these two critical points. Well, let's take a look at our expression for the derivative. We have this thing here. If we plug in a huge negative number, then this thing will be a huge negative number. This thing will be a relatively small number because remember this is like 1 divided by x to the 2/3 power, so if x to the 2/3 power is really big, which it will be if x is a large negative number, then since we're dividing by a large number, this term goes to 0. And we're just left with the effect of this term, and therefore the sign is negative. Now as x goes to infinity, again, this 1/3 x to the negative 2/3 power will go to 0. This term will go to positive infinity, so we have this here. Then the question is, what happens if we plug in a negative number that's close to 0? Well, the cube root of a negative number close to 0 is just a small negative number. But this term here, it's always positive because of the squared. But as x approaches 0, this term goes to positive infinity. And therefore, we have a plus sign here, because even though this term was negative, this term is going to be a huge positive number. And so we get this plus sign. So we have, by the first derivative test, negative 1/3. Since the derivative changes from negative to positive, it's a local min. And since the derivative does not change sign at 0, 0 is neither a max nor min. And the function ends up having a vertical tangent line at that point.